Let's have a look at problem 1701, average waiting time. This is today's daily challenge problem. So we are going to solve this problem by linear scan. So first, let's quickly look at the problem statement, and then we are going to make some key observation. So here, there's a restaurant with a single chef, and we are given an array called customers. So here in the problem in the function signature, I changed this to be a capital C for convenience. So the customers I, or generic customer, contains two elements. One is arrival time, and another time is the wait time, or the time for the chef to finish serving this customer. So the arrival times are sorted in non-decreasing order. So this is a very important assumption for this problem. And when a customer arrives, he gives the chef his order, and the chef started preparing it once he is idle. The customer waits until the chef finishes preparing his order. The chef doesn't prepare food for more than one customer at a time. So actually this assumption greatly simplifies the problem, right? So the chef prepares food for customers in the order they were given in the input. So this is also an important one. So we want to return the average waiting time of all customers. So here's another assumption. So solutions within 10 to the power negative 5 from the actual answer are considered accepted. So here are two examples. In the first example, so you can see the first customer arrived at time 1, and we need say 2 unit times to finish. So the waiting time for customer 1 is always 2. So when finish time is 3, right? But at this time, the second customer is already arrived. So the second customer arrive at 2, right? So for the chef to finish, it needs 5 unit times. So the finish time will be 3 plus 8, right? So because the second customer arrives, 3 plus 5, that is 8. Because the second customer arrives at 2, so the waiting time is 8 minus 2, that is 6. So this is the first customer waiting time, right? And then so here finish time is 8, right? So the third customer arrives, so third customer arrives at 4, right? But because at that time the chef is busy, so we can only start making his food at time 8. So the finish time will be 8 plus 3, that is 11. Because the third customer arrived at 4, so the third customer wait time is 11. The end time minus the time he arrives, that is 4. So in other words, we get 7. So the average wait time is nothing but 2 plus see here 6 plus 7 divided by 3, right? So that is 5. So here the division is integer division. So this is basically the first example, right? So here the length of the customer is bounded above by 10 to the power 5. So this is a large number. And the arrival time is in this range, and arrival is less than or equal to is increasing, right? Non-decreasing. So this is the relation. So here what I'm going to do is to do it in a linear scan. So here the key assumption is that the arrival times are sorted in non-decreasing order, right? So this actually simplifies the problem. So we can assume the previous customer left at time say previous go, right? So then we can scan the list. So if customer I arrives at current time with dish preparation, then the time is current wait time is current dt. Then this customer leaves at the time. So because we always need this time to prepare the food, the chef either start prepare this food at here or at the current come time, right? So if the customer comes after the chef finishes the previous dish, then the chef can immediately work. Then the wait time for the current customer will be current dt. So if the customer arrives before the previous customer left, then the wait time will be this one, right? Previous go time plus the current dt, then minus the time the customer comes. So once we get the total waiting time, we just need to divide it by the number of customers. Let's do the coding according to the above analysis. So first, I'm going to define a wait time. So we're going to accumulate all the waiting times of each customer. Then we just do average. Then assume that the previous customer left at time 0. So this is you can see it's a dummy one, right? And then we can do a for loop. So for come time for the ith customer, you can think of it like this. Then delta t in this list. Then if come time is greater than or equal to the go time, in other words, when the ith customer comes, then the chef is not busy. So the wait time for this customer is nothing but delta t, right? So we just increment the wait by dt. Then this customer left and the go time will be the come time plus this delta t, right? Otherwise, so in other words, the customer arrives, but the chef is still busy, right? And then in this time, so the chef will finish the work is go. The previous go time is go plus dt, right? And then the wait time will be the finish time minus the time when the customer arrives, that is go minus come, right? Then after this for loop, we accumulated all the waiting times for each customer. Then we just need to do average. So wait divide into the division by. So here I guess this. So here is not integer division. So here is 5.0, but here I can write 5, right? So here is division by the length of the list or the number of customers. Let's do a test. So here, let's see where wait. So here is increment, right? So let's submit. Yeah, it passes all the cases. So now let's change this code a little bit to make it more compact. So I'm going to make this one version v1, and then what I'm going to do is just use this relation, right? So because we just need to know, so for each customer, the wait time will be the time the customer go or left, and minus the time the customer arrives. So let's write like this. So wait equals 0, right? So previous go, let's call it, let's use it 0, right? Then for current arrival time and for time in this list, then the current go time, so it equals, so anyway, we need this time for preparing the dish, but we want to find the start time. So it will be the max of this current come and previous go, right? So if previous go greater than or equal to the current come, then we need to start preparing the dishes at this time. if current com is greater than previous go, we just immediately start serving at the time the customer arrives. So this is the current go. And then the wait time, the current customer wait time will always be current go minus current com, right? So then we just need to increment this. So the total wait incremented by the current waiting time, right? Then we need to set the previous go time will be the current go time. And then after this for loop, we just need to return wait divided by the length of this list or the number of customers. Let's do a quick test. Yeah, it passes all the cases. I guess for this problem, the main thing is to notice that so for each customer, the waiting time will always be the time the customer left minus the time the customer arrives, right? So with that said, I guess that's about it for this current problem. So for some extensions, you can see this similar problem. So this will be a very interesting one. So with that said, I guess that's it for the current video. Thank you.